to the next one. I will ask for B. Does anybody wish to give me B? Okay, let's try going on to this page. Number 1. Okay, number 2. Okay, tired of this. Moving on to page 136. There will be a quiz on adding and subtracting rational expressions tomorrow. So I hope that you guys get some of it done. So I'll show you the right answers tomorrow, and maybe you can mark it then. And we'll have the quiz at the end of the block. Moving along to solving rational equations. Yes. No, I cannot. So we will be moving on to equations. Tomorrow I will expect, when I ask for some of those, that somebody will offer an answer. Okay? Okay. Also, expect me to walk around tomorrow and make sure that 132 to 135 is done. Okay? Okay. Moving along, an equation. Please remember, an equation is what? As opposed to an expression. Excellent, it has an equal sign. So that would make this an equation, right? He waited patiently for a yes or a no. That's an equation? Yeah, it's got to equal something, yes? An equation has to equal something. I like to say it is an expression equaling an expression. You have to have both. What is our job? Pardon me? Yes, we will be simplifying. That is the steps we will take to complete our job. What is our actual job when we are faced with, let's change this to make it something that would actually work. 9 minus x. What would our actual job here be? Find x. Now, of course, we always say find x, and then every math teacher has seen that stupid cartoon where the question says find x, and the kid circles x and says, there it is. Every math teacher shows that out, and then everybody's like, we're all supposed to laugh because everybody that does our professional development things shows us that gag like it's new, and we're supposed to laugh at it like we did 25 years ago when we saw it for the first time. It's not funny anymore. But they still do it. So yes, we are going to find x. What that means is we are going to isolate the variable in order to assign it a value. Now, you guys have been given ways to solve equations all the way up to, you have practiced 3 different variables and 3 equations. That method of solving that many equations applies no matter how many variables you have. You can always use that systems thing. So we are going to work exclusively now. Now, we did radical equations earlier in the year, yes? We are going to work now with rational equations. Now, before I go any further, a rational equation is obviously just a rational expression. And I'm writing it this way to show it's written as a fraction. Oh, crap. One sec. There it is. Equaling another rational expression. And obviously, like every other thing we have ever done in math, nothing changes. our goal is still to isolate the variable in order to assign it a value. Okay? Now, every time we are given a rational expression, there's some things that we are already supposed to do, yes? Before we get to an equation, if we were only looking at one side of this equation, what is something in this unit that we would have done with that? Cool. Pardon me? Simplified. Absolutely. And what are our simplification tools? What do we use? When I say simplify, you all know what to do. What is it that we are doing in this unit when we simplify? What are some of the mathy things that we use? So step one, as Cole says, is simplify. How do we simplify usually? What is one of the things we do? Factor. Excellent. We factor. And what's the next thing we do? Once we have it broken down into factors, what do we then start looking for? Pardon me? Not yet. We're going to do any canceling that we can. What is something else? Now, what do we got to do? We got to think, yeah, you're probably right. I probably should put restrictions before canceling. Good point. Starts with an R. Yes, restrictions. We will state our non-permissible values. And what are those non-permissible values? Any denominator can't equal 0. Right? Everybody good? Everyone's good? Okay. So the next thing we're going to do, what do you think is next? It's a rational expression. It's a fraction equals a fraction. Or maybe more fractions. Maybe there's another fraction here. What would you do next? We've simplified everything. We factored it all out. And now we're left with this. What would you do next? Because for it to be an equation, we've probably got that in there somewhere. What would your next move be? Yeah, that's the canceling part of things. Yeah. But what am I going to do once I've done all my canceling? You guys just did, well, you were assigned 4 pages on it. What did you do on all those 4 pages whenever you saw an operation? Yes, Cole? You're going to isolate X. So I'll help you guys out. I'll give you an example because we seem to have hit a bit of a roadblock here. What if you were faced with this? You have done all your simplifying, and you are now here. What do you think you will do now? Because I haven't actually shown you what to do. I'm just seeing if you have been following along with all the work that we have done so far. We have factored something down. We have done every bit of canceling we can. And now I am here. Pardon me? Of course you would find a common denominator, but there's a catch here, isn't there? Yesterday, and the day before, and the day before, and the day before that, when you were all doing the homework, you only had this side to deal with, didn't you? Right? What's different today? There's an equal sign. This is an equation, isn't it? So there's a whole nother denominator there that we have to take care of. Right? Right? Now, if I take care of all these denominators, and they all have the same denominator, then where does the math have to happen? And I'll give you an example of what I mean. If I gave you this, I don't want to make that over 2. I want to make that, oh yeah, that can be over 2. Oops. Where in that red equation are you going to need to do work? Pardon me? In the numerator, yes? Because once we have the denominator all the same, do we care about it? Right.
The denominator is 2 is going to be times by x, and then for the second one, since it's x, we times by x.
But the problem is, in this section, what do we do over here? That's the new thing, right? But you all know that once we figure out what to do with that new thing, we know what to do, don't we? Right? So we get our LCD in order to eliminate denominators. And then what do you think we do with just the numerators? What math do we perform here on these? Oh, that should have been green, yellow. What math do we perform here on these numerators? Do you think? Again, I haven't actually showed you. I'm asking you to synthesize some information from what you already know. Now, you have been told that we are down to here. You have been told by Sophie, and I've agreed that all we care about is the numerators. So what must we do with those 3 numerators if we got to that point in a question in this part of the unit? We're going to add them, okay? And when we add them, we're going to end up with x plus 7 plus 3 equals 16, yes? Okay, now what are we going to do? Solve for x, using what the principles of what part of math? Algebra. Excellent. We are going to perform as soon as my computer doesn't respond. We are going to perform algebra on what? Just the numerators, yes? So we are going to do algebra on the numerators because we don't care about the denominators anymore because they're gone. Right? Everybody cool? Now that will take us to an end spot. It will take us to x equals something, yes? But once we are there, there's one more thing we must do. But I'm not going to go to there yet because it requires discussing a new thing that I don't want to discuss just yet until we're there. I want to practice this once or twice. So let's look at that first one. Can we do any simplifying, factoring, or canceling in 1A? I can not get rid of that. And that's driving me up the wall, but whatever. I do not need to restart this computer, so I'm not going to. Can we do anything from 1 or 2 in that first question? Is there any factoring to be done? I'm looking to simplify. Can I do it? It's a yes or no question. No, I can't, right? X divided by 4, 7 divided by x equals 3. Simplify. We can't do it. So we're done. It's already as simple as it's going to get. Yes? 2. Let's check for restrictions. Are there any? Is there any number in the universe that x cannot be? Why? Can I ever divide by 0? At any point, ever? No. So x can't equal 0. So that's done. All right. So now we've got to do, now we're getting to the kind of new stuff. Last block that you were here, you didn't have to deal with that. Oops, that was bigger than I wanted it to be. You didn't have to deal with the 3, did you? So what did you do here on Wednesday, Thursday, Friday, Saturday, Sunday when you were practicing all this math? What should you be looking to do right now? Common denominator. Excellent. What's the easiest way to make a common denominator if you're not sure? Multiply them together, yes? So what happens when I multiply those two denominators together? What do I get? 4x. Excellent. So number 3, my common denominator, and I'm not going to write lowest common denominator because it's not always the lowest when you use that trick. My common denominator is 4x, yes? Which means every term must have the denominator 4x, yes? Everyone agree? Okay, so now I'm going to bring this 3 back. Every term has to have 4x, yeah? Okay, so I have 4, I have x, and I have nothing. So I'm going to do a little bit of highlighting because I find this to be helpful when I was learning. I got 4 and I got x. What do I have in the first term? The 4 or the x? I got the 4. So what does he need? X. So if this has to multiply by x, what does the top have to multiply by? X. And what do I get? X squared. Is everybody cool? Everybody's good? Okay. What do I have in the next term? I have just an x, yes? And what do I need? 4x. So what must I multiply the second term's denominator by to get the denominator that I am seeking? I need to multiply it by 4, yes? So that guy gets 4 and that guy gets 4. What do I do there? I have x minus 2 minus what? 28 over 4x right now, yes? Okay. What denominator is right there? 1. What do I need it to be? 4x. So that's got to multiply by 4x. What does this guy have to multiply by? Giving me what in the numerator? 12x over 4x. Does everybody understand everything I've done so far? Now, because all of these are the same, I can get rid of them now. Because all the math is happening upstairs, yes? So what do I have in the numerator right now? I have x squared minus 28 equals 12x. Now, have we done any math this year that deals with an x squared and an x and a constant? Of course we have. What do we do with that? We factor it. We can't factor it now, though, can we, Max? We got to bring this guy over here so it looks like something that we are dealing with, yes? So what will we get? We will get x squared, then what? Minus 12x, well done, minus 28. But what indeed does that equal? Because when I move that 12x, there is now nothing there, and I don't have an equation anymore, do I? Or do I? Yeah. There's nothing there, so we can just equal 0. Now do we have an equation? Now does this look like something we have dealt with many, 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 many times? When we factor it, what will we get? We will get x minus 14 and x plus 2, won't we? And how do we solve that? Because that looks a lot like something that we dealt with all through the quadratics unit. Doesn't it? What does x equal? 14 and negative 2, right? Now, does that work with our restriction? Is x allowed to be 14? Yes. Is x allowed to be negative 2? Yes. Should we check? It takes 2 seconds. Well, it doesn't really. It takes a little longer than that. But we know we're right, yes? Now, I said there was one other thing to check. We got to check for non-permissible values, yes? And that's checking against this. But we also have to check for extraneous values. Does anybody remember what an extraneous value is back from our radical equations? Does anybody remember that? Just to remind you, if I had this for you, the square root of x plus 4 equaled 8. How would you solve that? Thinking back to the second or third unit. You'd square both sides. X plus 4 would equal 64, yeah? Right? And then you would do what? X would equal 60, right? And we'd be okay, because 60 plus 4 would equal 64. Square root of 64 is 8, yeah? Everybody cool? Okay. Now remember that sometimes when we square, we ended up with plus or minus, yeah? We ended up with two things, right? And one of those things, when we put it back in the equation, didn't work, correct? That's an extraneous value. So we dealt with them already. We may have to deal with them again. So right here, I want to remind you, this was number 4, all of this. And then number 5, we checked our non-permissibles. But we also got to check for extraneous. And when we come across some of them, I'll remind you. Okay? But if we get to the point where we have checked everything, and the question's out of 5, you're already getting 4.5. Do you understand what I'm saying? I'm not as worried about the extraneous stuff until the very, very end of the section. Do you understand what I mean? Because there's so much going on in these questions that little last thing, for me, is not very important right now. Is everybody cool? All right. So let's look at B. Whoa. Let's look at B, and let's talk about what we can do with that. You guys have a look at that for a moment. Talk with your neighbor if you wish. Talk with yourself. I do not care with whom you speak. Decide what you are going to do with B. Would anyone like to volunteer one of their first steps? I do not care what it is. Would anyone like to give us a way to get started? Pardon me? Yes, thank you. So Jazz Kirat has said we are going to factor right there, yes? And he factored it beautifully. 2z plus 2, z minus 2, plus. What's happening? Does anything happen in the second one? Does anything happen here? Burke has said he does not like that 6. So we will bring that 6 out, and we will get z plus 2 over 10. And that will equal 1 over z minus 2. Is everybody happy with what we have done there? If you did not volunteer, did you all at least do that? Everybody did? Okay, now, what should I do right now? Before I cancel, I got to check my non-permissibles. What is Z not allowed to be? Plus or minus 2. Why, Megan? Because right there, I can't have plus 2 or minus 2. And that plus 2 and minus 2 covers that one, because that guy can't be minus 2. And the plus 2 covers that one, because that guy can't be plus 2. Everybody good with restrictions? Okay. So now, what's next? We've simplified. There's nothing to cancel. What is our next thing to do? How, indeed, are we going to add those two rational expressions? What must we do? In order to add two rational expressions? I could call your attention back to the previous question, because that's how math works. What should we find when I am trying to add two rational expressions? A common denominator, indeed. And what is it? What are all the elements of a common denominator? I must have z plus 2, I must have z minus 2, and I must have a 6, yes? Everyone agree? Okay. What do I have in term 1? Do I have the z plus 2, the z minus 2, and the 6? No. What is the only thing missing from the first term? The 6. So what must multiply over here? 6. Excellent. What about the second term? What do I have? In the second term, I need z minus 2, don't I? So this guy's going to get z minus 2. And what must I have in the third term? 6. Z plus 2, yes? And z plus 2. Right? So let us rewrite this. What is 6 times 2? 12. Plus. What, should I leave this way, or should I distribute that 10 in? Do you think? Does it matter? Do you think? Previous to now, we wouldn't have distributed that in, yes? Because previous to now, we were only simplifying, right? But we know we're canceling all of these denominators, aren't we? Don't we? So we better distribute this one in, yes? Because we don't need to keep it separate, because we're trying to solve for z later, aren't we? And that z later is going to become 10z, isn't it? So what should I do right now? Distribute. What am I going to get? Plus 10z minus 20 equals, now here is where kids screw this one up. What is over here? 1 times 6z plus 2. What is over here? Six Z, okay, I've heard that a few times. It's a tricky one. One times 6 times Z plus 2. Plus 12. Whew. That was a tough one. Now what? All that's over our denominator, so we don't care about that anymore, yes? Okay, so what do I do with that? I'm going to write this out just to remind you. This is all over that, technically, right? So we could do our restrictions there too if we wanted to. But what is happening there? They are all gone. So what math must happen with that denominator, or that numerator now? Starts with an A, ends with an A. Algebra, excellent. What will we do with that side? You will collect like terms, and you will get what? I would write 10z minus 8, but that's cool. It's the same thing. Equals what? Six z plus 12. And then what will you do? You'll do yet more algebra. I can't do any more algebra, because this is an epic freeze of the computer. But while you guys are waiting, you'll perform all the algebra you need to do on 10z minus 8 equals 6z plus 12. What are you going to do there? Pardon me? You're going to move the 6 over there to get what? 10z minus 6z. And you're going to move the 8 over there to get what? Plus 8. What's 10z minus 6z? 4z. What's 12 plus 8? 20. Now what? Divide by 4. And what does z equal? 5. Is that okay with our restriction? Yep. And does it work? Most likely. We could check it, but we know it's going to work because it worked in the numerator. So you guys now have a look at that one. What do you got to do first? I'm going to talk less and await answers more. What should I do first? Simplify everywhere I can, yes? So, any simplifying on term 1? Nope. Term 2? Term 2? Nope. Term 3? Buckets of simplifying, yes? So, first two are staying the same. 4k minus 1 over k plus 2 minus k plus 1 over k minus 2 equals, what do I simplify out there? What is that going to become? You know what? I need to stop for a second. I need to just stop for a second. How many of you, I'm going to ask this, I'm going to change my tactic here. How many of you want to simplify that, want to simplify that right now? If I hadn't said anything, how many of you would have gone to there and simplified? Just be honest. Okay. if you do that, what's your next step after we simplify everything? We got to do some multiplying, yeah? Now, if I break that down, and then I got to multiply it by something, is it feasible that I might end up with k plus a, k minus a, and then have to multiply by another factor when I have to simplify it later? Do you understand what I'm saying? So let's just leave that alone for a moment and see what happens. Over what? What's going here? K plus 2, k minus 2. Now we can plainly see that we could simplify here now, right? Why did changing that one bit of order, why was that a good decision? Because we notice that right here, what is that? When I compare it to over here. That is the common denominator, isn't it? So I know I don't need to change that guy, do I? Right? So now I know I'm going to be factoring him later, but some stuff's going to happen over here first, isn't it? So we know that this is our common denominator. And I don't necessarily want to factor him right now because I know later on stuff might be moving around, right? So we're not going to touch him yet. I'm going to keep him highlighted because we're going to come back to that guy. If our common denominator is this, what is this guy missing? What does term 1 need? I just wrote term 2. What does term 1 need from this denominator? K minus 2, correct? So this is going to be 4k minus 1 times k minus 2, right? Minus, what does term 2 need? K plus 2. K plus 1, k plus 2, correct? And that is going to equal k squared minus 4k plus 24. And I'm keeping him highlighted because we haven't done anything with him yet, even though we all wanted to do something with him, didn't we? Why didn't we? Because what's happening over here now? What am I going to get? I'm going to get a bunch of k squareds, a bunch of k's, and a bunch of constants, aren't I? So if we messed with this guy now, we'd be in trouble over here, wouldn't we? Right? So what do you want to do with that? Pardon? FOIL. Great. What is it? And then what do you want to do with that? FOIL again to get k squared plus 3k plus 2. Yes? Equals k squared minus 4k plus 24. What's happening on this whole side of the equation? What do I do with 4k squared and minus 4k squared? What do I do there? Subtract. So what do I get? 3k squared. What do I do with minus 9 minus 3? What do I get? Minus 12k. And what do I get with 2 minus 2? 0. So I don't need to write it, do I? And what does that equal? K squared minus 4k plus 24. Now, do you see why I left this guy alone? Because if we'd factored him, we'd have two binomials there, wouldn't we? If it even factors. I haven't even looked, right? It doesn't factor, so we couldn't have factored it anyway. What do I do now? This is where you guys, not you guys, but this is where a lot of kids make mistakes. What do I do now? I got to move everything to one side, right? But here I got to make a decision. If I just move everything to one side, I might end up with extra work to do, yes? If I move this here, is that okay? It's okay, but it's going to give me a negative, isn't it? Which is going to make me have to do one more step of work, right? And every time I do one step of work, is there the potential for a mistake? Even if I know what I'm doing, right? You guys watch, I make mistakes up here, don't I? And we all know how easy it is to put a plus or a minus in the wrong spot, yes? So I like to take a step and think about what will keep me as happy as possible. So I'm going to move the K, I'm going to move everything this way to keep my first term positive. Everybody cool with that? So what am I going to get on the left here? I'm going to move that over to get what? 2k squared. Then I'm going to move that over to get what? This is where it gets tricky. So I have minus 12. When I bring that 4 over, what does it become? It's already negative. So it becomes positive. And what do I get there? Minus 8k. Excellent. And what do I do with that? It's going to be negative 24, yes? And what is that going to equal? 0. Everybody cool? Okay. What then would be, if I was in the 10th grade and there was no equals 0, what would I do with the left side of this equation right now? You could. But isn't there something you can do before we multiply 24 by 2? What would I do? GCF. So I know that as soon as I see that, I got to factor. So let's factor. Just here it says we got a GCF. What is the GCF? What is it? 2. So out comes a 2, and what do we get? We have factored that many times. K, what is it? What? K plus 2, K minus 6. So what then is K going to be? Negative 2 or positive 6. Now, are both of those allowed? Which one isn't allowed, Yoon? Negative 2. Why? Because our restriction right up here says no negative 2. So what do? Is that an answer that I'm allowed to have? No. It's gone. Why is it gone? Because of my restrictions. I didn't even check my restrictions at the beginning. I completely forgot. So what's the only answer? K equals 6. Now listen to me. How will people mess with your head with this? If they give it to you on a multiple choice test, what will choice A be? K equals what? Negative 2 and 6. And how many of you would circle A? Be honest. A few of you would, wouldn't you? Right? Does that tell me, what does that tell me as your math teacher? If you got all the way to here, how much math did you do? Crap loads. Right? Now think about the new way I'm supposed to be marking you guys. Minimally meeting expectations, approaching expectations, meeting expectations, exceeding expectations. Right? If you forgot this, where do you think you fit on that 1, 2, 3, 4 scale? Just out of curiosity. 3 would be meeting my expectations. Not a great scale, is it, for math class? Right? How many of you feel good about a 2 on a 4-point scale? I wouldn't. Would you? Even though 2 is minimally meeting expectations. But sadly, in math class, things are right or wrong, aren't they? Right? In an English class, are things right and wrong? Not usually. In a social studies class, are things right and wrong? Sometimes, but just as often that it's not, is it? Right? And even in math, sometimes there's gray areas, right? So it makes it difficult to mark. And of course, choice D would be K equals 6. Right? Now, in a multiple choice test, you circle A, you've got it wrong, even though you did all this work correctly. That is why I don't like multiple choice. You guys all love it. I hate it. Because it's right or wrong. Even if you do all the work correct. Look at all this math we did. This one question covers how many grades of high school math? Everything you've ever done in one question, right? Does it make sense to make it a multiple choice question? I don't think so. All right. I'm going to stop there because I have a sneaking suspicion that a great many of you need to have a look at 132 through 135 again. So I am going to assign you 137 because that is the only new thing for Tuesday. But there's going to be a quiz on 132 to 135 tomorrow. So I hope that tomorrow morning, when I ask for some answers from 132 to 135, that it will appear that more of you have done it. Also, were I you, I would expect one of the rare homework checks tomorrow to see if indeed anything from 132 to 135 is done, other than the first 3 questions that I did for you on Wednesday. Okay? Okay. 28 minutes in this class to get some of that done. Go.